go back with the examples, let's have first the different steps in graphing a parabola. So step number 1, to graph a parabola in a rectangular coordinate system given its standard form of equation, first, determine which of these standard forms applies to the given equation. So we have different forms of equations depending on the opening of the graph of the parabola. The first one would be for those which opens to the left or to the right, that is, the quantity of y minus k squared equals positive or negative 4c times the quantity of x minus h. Okay, for those which opens to the left, that would be negative, and for those which opens to the right, that is positive. Then we also have another form which is for those which opens upward or downward. So that is the quantity of x minus h squared equals positive or negative 4c times the quantity of y minus k. For those which opens downward, that is negative. And for those which opens upward, that is positive. Second, use the standard form identified in step 1 to determine the axis of symmetry, focus, equation of the directrix, and endpoints of the lattice rectum. Okay, take note of the following. If the equation is in the form the quantity of y minus k squared equals positive or negative 4c times the quantity of x minus h, again that is a graph opening either to the left or to the right. So the axis of symmetry is y equals k. 4c will be the coefficient of x in the given equation. So to solve for c, if c is greater than 0, that is positive, the parabola opens to the right. And if c is less than 0, that means it's negative, the parabola opens to the left. To find the focus, we'll use c. So the coordinates of the focus will be h plus or minus c and then k. And then we can also use c to find the equation of the directrix. The equation will be x equals h plus or minus c. And then we can also use c to find the endpoints of the lattice rectum, LR sub 1 and LR sub 2. Okay, speaking of LR sub 1 and LR sub 2, if the graph opens to the left, we use LR sub 1 as h minus c, k minus 2c. And LR sub 2 is h minus c and then k plus 2c. Now if the graph opens to the right, LR sub 1 becomes h plus c, k minus 2c, and LR sub 2 is h plus c and k plus 2c. Okay, this time if the equation is in the form the quantity of x minus h squared equals positive or negative 4c times the quantity of y minus k, that would be the graph or the equation for the graph that opens downward or upward. Then the axis of symmetry is x equals h. This time, 4c will be the coefficient of y in the given equation. To solve for c is greater than 0, that means it's positive, the parabola opens upward. And if c is less than 0, that means it's negative, the parabola opens downward. We can use c for the following. First is to find the coordinates of the focus. That would be h and k plus or minus c. And then the directrix or the equation of the directrix, that is y equals k plus or minus c. Lastly, it can be used to find the endpoints of the lattice rectum. Again, speaking of LR sub 1 and LR sub 2, we have for the graph that opens downward, that would be LR sub 1 is h minus 2c and k minus c, while our LR sub 2 will be h plus 2c and k minus c. And for the graph that opens upward, we have LR sub 1 equals h minus 2c and k plus c. And LR sub 2 is h plus 2c and k plus c. Lastly, for step 3 in graphing, plot the focus, directrix, and lattice rectum and draw a smooth curve to form the parabola. Remember, it must be a smooth curve, not letter V. It's a smooth curve. So we have the figures on the presentation.